Alright guys, so we're going to do addition. From our functions on number 1, we'll do subtraction, and then we're going to have to talk about the domain, and then we're going to evaluate. So add, then subtract, do domain, and then evaluate. So we got 4 things to do for each of these problems. So number 1, they're going to f plus g of x will give you one of those cube roots of 4x plus negative 9 of those cube roots of 4x. And because these are in the same family, it's just the cube roots of 4x family, I can combine these two together to negative 8 cube roots of 4x. When we look at our graph on the calculator, we have our negative cube root function that looks like this. So our domain is going to be all real numbers. Now we're going to do f minus g at x. And that is still going to give us the same kind of process here. We have 1 cube roots of 4x minus 9 cube roots of 4x. Alright, so the same general principle applies. We have cube roots of 4x and cube roots of 4x. So these two families can be combined together. And I need to remember my sign rule here that a negative and negative will give me a positive. So this gives me 10 cube roots of 4x. Now my slope switched from negative to positive rate of change. So that means that my function will take a positive slope to it. Again, same thing, domain is all real numbers. And now it's time to evaluate. They ask us in number 1 to evaluate where x is negative 2. So f plus g of negative 2. We're going to go ahead and substitute this into our calculator. So negative 8 cube roots of 4, and there's my substitution. Here's negative 2 going into the equation, and that equals 16. Now we'll do the subtraction. F minus g at negative 2. Again, we're going to take this to the calculator and have it solve this out for us. 4 times negative 2 is negative 8. The cube root of negative 8 is negative 2. And negative 2 times 10 is negative 20. And that's how we solve for number 1. Alright, number 2. They give you 3x minus 5x squared minus x cubed as a function. It's not quite written in standard form, so we're going to go back and write f of x as negative x cubed minus 5x squared plus 3x. And then we'll write our g of x function. G of x is in standard form, it's just 6x squared minus 4x. So let's add these up. F plus g at x is negative x cubed minus 5x squared plus 3x. In the last problem, I showed us how to combine our like terms side to side. And I'm going to demonstrate a different strategy here where you're going to stack the equation one on top of another. In my g of x function, I don't have this x cubed family, but I do have the x squared family. So I'm going to leave the first space blank and just put in plus 6x squared and then minus 4x. When I go to add all of this up, I can just bring my negative x cubed down. I'm going to have plus 1x squared and then minus x. This is another one of those cubic functions. Another one of the cube root functions, and it has a negative slope. So we know that the domain is going to be all real numbers. It's going to match this one up here. It's got a negative slope as a cube root function. Now let's do our subtraction. F minus g of x is going to be this exact same setup, the same thing, only now we're going to subtract the entire bottom line. So we can write the same thing over again. Negative x cubed minus 5x squared plus 3x. And then now here's my subtraction. I'm going to write 6x squared minus 4x. Remember that this subtraction sign will apply to the whole equation now, not just one term. So we'll bring this down. Negative x cubed. And then we're going to have negative 11x squared. And then a negative and a negative is a positive, so that'll give me 7x. Alright, negative cube root function, so it matches what we just saw up here, which matches on the first one, so it looks like this. Our domain will be the same, all real numbers. There's my domain. And then we need to substitute in. So f plus g of x, where x, in this case, is just going to be the number -1. So we're going to have this equation right here. Now we're going to substitute in -1. So -1 cubed plus -1 squared minus -1. Lots of sign changes in here, so you really want to expand this out so you know what you're doing. So this is negative times -1 plus 1 plus 1, and you can see a negative and a negative is a positive. A negative times a negative is also going to be a positive. This is an odd root. This is an odd exponent, so it's going to stay negative, and this negative is still out here. A negative and negative is a positive. So altogether, this adds up for us to 3. So f plus g of -1 equals 3, and now we'll do f minus g at -1. And we have got the same exact equation here, right? We're going to use this one right here. Alright, so f minus g of x, we named this is -1 cubed minus 11, -1 squared plus 7 times -1. Again, this is all going in our calculator, and we can do some of this in our head. -1 cubed is -1, negative and negative is a positive, so this is +1. -1 squared is +1. +1 times -11 is -11, and this will be -7. So altogether, when we add this up, for number 2, we're going to get -17. F minus g of -1 equals -17. Good deal. Alright, so that takes us through the addition subtraction piece of the function of the worksheet, and we're going to tackle 3 and 4 next. Alright, 3, 4, and 5. So number 3 is multiplication, and we're going to multiply f times g at x. So 3x cubed times the cube root of x squared. You gotta be really careful with this x squared though, because it is underneath the radical, and that means something else than having it up at the, let's say, at the top up here. So let's rewrite this expression now using a fractional exponent. So this is going to be multiplied by x squared in the parentheses, and then raised to the 1/3 power. Alright, so 3x cubed times x, and we'll use the power of a power property to multiply our exponents together. 2 times 1/3 is 2/3. Now I'm multiplying my like bases. So I have 3 times x cubed times x to the 2/3 power. And when I have a power product of the powers here, I can just add my exponents. This right here. So 3 plus 2/3. I can rewrite 3 as an equivalent fraction of 9/3, because 9 divided by 3 is 3. And what that'll do is give me a common denominator. 9 plus 2 is 11, and then we're going to have 11/3. So I just did my little exponent problem right over here off to the side. And I found that what's going to happen is we're going to have 11/3 as our final exponent up here. So altogether we have 3x to the 11/3 power. And that's going to be f times g of x. Alright, when we go to f divided by g of x, you'll notice that the process is almost identical again. We have 3 times x cubed divided by the cube roots of x squared. From here, we're going to get this into a like base. So we're going to have x and x here. So we have 3 times x cubed divided by 1 times the x Now we can just subtract our exponents. So this one is going to be 3 minus 2/3. And 3 minus 2/3 is 7/3. So this is our new exponent. And we can just say that this is 3x to the 7/3 power. There's our division. Now let's go ahead and talk about domain and range. Because these are all cube roots, right, the denominator is 3. We're talking about the function, the cube root function. So we know that for both of these, your domain will be all real numbers. When you go to substitute in on number 3, they want you to actually substitute in for where x is -8. So when we have f times g of -8, we're going to have 3 -8 to the 11/3 power, like this. And that gives us, on our calculator, we get -6144, 6,144. When we divide f divided by g of -8, we're going to use our new equation over here, which was 3x to the 7/3 power. So 3 times -8 to the 7/3 power. And that one is -384 in our calculator. Alrighty here, number 4. And number 4 is just the same thing. We're gonna get some more practice, multiplication and division. So we are gonna use f times g of x equals 3x squared times 5x to the 1/4 power. So 3 times 5 is 15. And then we're going to have x squared times x to the 1/4. This rule right here, this is the one rule that we can actually use to add up our exponents. So we're going to have 2 plus 1/4. And in other words, 2 over 1 plus 1 over 4. The problem here is I don't have the common denominator. So if I multiply 1 times 4, I can multiply the top by 4 as well. 2 times 4 is 8. So now 8 over 4, 8 divided by 4 is still 2. I haven't changed anything. It's an equivalent fraction, but it allows me to add my exponents as a common denominator. So 8 plus 1 is 9. This is going to be 9 over 4 as my exponent on the x. Equals 15 times x to the 9 over 4 power. F divided by g of x is going to be the same deal. We've got 3x squared, and we're dividing it by 5x to the 4th. So we're going to do the same thing. We have 3/5 here, like that. And then we're going to subtract these exponents, where it is x squared minus x to the 1/4. Excuse me. So we're going to have 2 minus 1/4. 2 over 1 minus 1 over 4 on your calculator gives you 7 over 4. So you're going to have 3/5 x to the 7 over 4 power. And that'll be your final answer. When we go to substitute in our work, they want us to substitute in for g of 16. So equals 15 times 16 to the 9 over 4. And that's going to be f times g at 16. And f divided by g at 16 is going to be 3 over 5 times 16 to the 7/4 power. Alright, so when we multiply 15 times 16 to the 9 over 4 power, we get 7,680 on our calculator. And then when we multiply, when we divide, our 3/5 times 16 to the 7 over 4 power we get 384 divided by 5. It's okay for us to leave this as the simplest fraction because it's going to be a pretty long decimal, and we want to make sure that we're most accurate, so we're going to leave it just as a fraction. Number 5. Number 5 has us going to multiply our 10x to the 5/6. We need to multiply by 2x to the 1/3. So we're going to take our coefficients first, and then we're going to multiply x to the 5/6 times x to the 1/3. When we multiply our powers like this, the whole reason that we can do this is so that we can add up our exponents. We're going to add up 5/6 and 1/3. I need a common denominator, so 3 times 2 is 6, so 1 times 2 is 2. 2 divided by 6 is still 1/3. 5 plus 2 is 7, and our common denominator is 6. So f times g of x is 20x to the 7/6 power, and f divided by g of x is going to be 10 x to the 5/6 powers divided by 2 x to the 1/3 power. Alright, so from here we do the exact same deal that we did last time. 10 divided by 2 is 5, and then now what we can do is use our quotient of powers and subtract these two exponents. So we're going to have x to the 5/6 minus 1/3. When we simplify this right here, 5/6 minus 1/3, we can double 3 to get to 6. 5 minus 2 is 3. So 3/6 is 1/2. So my exponent here is actually going to be 1/2 when I subtract. So 5x to the 1/2 power. And that's going to be the last exponent. All we need to do is substitute in. On this one, they're asking us for when x is 64. So f times g at 64 is 20 times 64 to the 7/6 power. And then f over g at 64 is 5 times 64 to the 1/2. Alright, we can put this into our calculator, and I'm going to do that now. When I put this into my calculator, I get 2,560. On the division one, I am actually going to do this in probably mental math. This is the second root, or the square root of 64, which is 8, and 8 times 5 is 40. So, if you wanted to, you could also just put this in your calculator to confirm that that's what you got as well. That's going to take us through addition, subtraction, multiplication, and division. The next thing that we're going to do, 6, 7, 8, and 9, they ask you to use a graphing calculator to actually evaluate these types of things for when x equals 5. So right here, we're going to do the same deal, only for these, they are not telling you like 64, 16, and -8. They're telling you specifically use 5. Okay. So we need to do all 4 of our operations, substituting in for 5. Now we're going to do these on our calculator. The first one we're going to type into our calculator on number 6. We need to type into our calculator where we multiply f times g at -5. So this actually should go faster than the last few problems because we just need to tell the calculator how to type this in. So we're going to do -3, and here's where we substitute in 5 to the 1/3, and then you want to add that on your calculator to 4 times 5 to the 1/2. When you do that on number 6, you add them up and you evaluate at 5, your calculator just spits out 3.810. And that's totally fine to leave it like that. You are just going to type it straight up like this into the calculator, and it's going to spit out the answer. And that's, you just want to get a little technology practice. F minus g at 5 is going to be -3 times 5 to the 1/3 minus 4 times 5 to the 1/2. Alright, let's type this into our calculator. Notice all the parentheses that I'm using here to make sure that I can keep everything in my order of operations. And I get -14 0.070 as my output. When I multiply f times g, again, I'm not doing any of this on real paper. This is all calculator based to speed things up. So on my calculator, I'm going to type in this, and it's a lot of parentheses. Negative 3 times 5 to the 1/3, like that. There's the first one. And then I'm going to put in my multiply sign, another parenthesis, and then 4 times 5 to the 1/2 power. Close that up. Now, when you've got all of your parentheses together, like this, then we can go ahead and just hit enter on the calculator. And that's going to come out at negative 45.880. And then we're going to do f divided by g at negative 5. The nice part about these types of things is on the Inspire, all you would need to do is copy the line above, paste it into where you're working, and then change the operation from multiplication to division. So it's literally going to be the exact same thing on the technology. You just want to go back in and put in your division sign here. Alright, so here's us dividing these two functions. On number 6, when we divide f over g and evaluate it at positive 5, we get negative 0.570. There's number 6, and number 7 goes equally as fast. It's the exact same thing. We're just going to switch out equations. Again, the practice here is to make sure that you can do this on your technology when they ask you this on the quiz and test. So we have f plus g at positive 5. I don't know how I started writing negative down here. Alright, so 6 and 5 to the 3/4 power, 6 times 5 to the 3/4 power, plus 3 times 5 to the 1/2 power. So on number 7, we're going to add up our functions, and we end up with 26.770. Now let's subtract our functions. Again, we evaluate for 5. So 6 times 5 to the 3/4 power minus 3 times 5 to the 1/2 power. I'm going to go ahead and throw some more parentheses around here. The bigger your equations get, you're going to want parentheses here because it's going to remind you to distribute the negative to everything that's on this equation. So if g of x had like x squared plus x, you want that all inside of this grouping so that the negative sign will distribute. Alright, again, you copied, you pasted, you changed the sign in your calculator, and now f minus g at 5 is 13.350. Real quick, we're going to do f times g at 5, and that's going to give me 6 times 5 to the 3/4 power, multiply by 3 times 5 to the 1/2 power. And again, I'm going to start using a lot of parentheses here because I want the order of operations to get preserved in the calculator. But it should look like this. And I'm going to hit enter in the calculator. And it's just going to spit out for me 134.580. Now we're going to do f divided by g and evaluate it at 5. And literally the same thing. You can go up here on your calculator. On the Inspire, you can press Control C. And then Control V. This is the copy command, and this is the paste command. So you can copy the line above, paste it into where you're working, and then just go in and edit the actual operation in between. So here, you'd paste in 6 times 5 to the 3/4 power, and then this is your division sign. This is what you edit. You want to change multiplication to division. Everything else should stay the exact same. And when you do that, what's going to happen on your calculator is just going to spit out 2.99. And it goes so fast, and that's the whole point, guys. This isn't, we know your calculator is doing the heavy lifting, so it's just about practicing this because we're going to need this skill for your assessments, okay? All right. Right, so on number 8, they're asking us to correct the student's error. And when you look at this, if you were to actually take 4x to the 7/3 and divide by 2x to the 2/3, look what's going to happen when you graph it. And I think that was probably the big thing that you wanted to do for this one, is actually put this on your graphing calculator to see what the picture is. And you're going to see that there's an issue in the graph, and it happens right here. Because if x is 0, if this is true, then what's going on is you're going to have f function divided by 0. And that's mathematically impossible. We can't divide this by 0. Like it's sort of strange to say I have 4 friends and I want to divide them into 0 groupings. That's like we just don't do that. It's impossible. And so that's what they want you to see here. The domain is not all real numbers when you divide. It's not, because x cannot be 0. So it's going to be almost all real numbers. Just as long as x doesn't equal 0, then you're fine. So I'm going to say domain is all real numbers, x can't equal 0. And this is the piece that the student needed. They need to go back and make sure that it's mathematically possible, that what they're saying is okay. All right. This last little bit, this little table, is kind of fun. It says use the table to evaluate f plus g at 5. So go to where f is 5, right? Like where x is 5. Okay, what is f plus g? Well, -7 plus 2 is -5. So that's my answer. F plus g at 5 is -5. And I got that by adding -7 plus 2, f plus g. Now let's subtract. We have f minus g at 0. So I go to 0. And f minus g at that place is 18 minus 64. So 18 minus 64 is -46. So f minus g at 0, -46. We're going to multiply when x is 3. So f times g at 3. 3 times 8 will give me 24. And then we're going to divide when x is 2. So f over g of 2. We come here to 2, and we get 8 divided by 16, which is 1/2. And that'll do it, guys. If you have any questions, please leave those in the comments, and we'll get you right back. Have a great day, and we'll see you tomorrow.